This presentation is delivered by the Stanford Center for Professional Development.
Well, good afternoon, everybody, and welcome to the Thursday, October the 18th, 2012, session in our series on green technologies and transportation, recent developments from Asia. And I'm Richard Dasher. I direct the U.S. Asia Technology Management Center that presents this series. And I want to start out by saying a special word of thanks to the Alan Miner Foundation for additional financial support of this series. We'll have some refreshments outside at the end of the program, and we hope you'll stay around and meet our speaker and talk with each other afterward. For those of you who are taking the course for credit, remember that your comments on the October 4th session were due by today. Please don't write comments between 4:15 and 5:30 today, though. Okay, I'll take them through the evening. So remember that your comments are due within 2 weeks of the session. Also, please make sure you sign the attendance sheet that will be passed out sometime during the session today. Otherwise, your on-site attendance won't get credited. But we're very glad that you're here. I've been enjoying reading the comments. I've had some really great insights from people who've been writing in the comments, and we may share some of them kind of without names to everybody as we go along. Today, we're very honored that Professor Hiroshi Shimizu has come all the way from Japan, basically to speak in our seminar today. He's leaving for the airport right after this and going back tonight via the ANA flight from Los Angeles. So we're very happy that Professor Shimizu would come and talk because he's really a unique person in the history of the EV in Japan. He's been working on electric vehicles in Japan for more than 35 years. He's led the development of more than 14 concept cars. And his PhD is from Tohoku University. And after graduating from Tohoku University, he went to the National Institute for Environmental Studies in Japan, where he was director of the Regional Environmental Research Group for 10 years. He joined the faculty in Keio University, which is one of Japan's leading private universities, in 1997. And in 2009, he created this company, SimDrive, which is all about bringing new drivetrain technologies into the marketplace. So I think that I should probably, without further ado, turn the microphone over to Professor Shimizu. Thank you so much for coming.
Thank you very much. I'm Hiroshi Shimizu from Japan. Thank you very much for inviting for such nice presentation place. And thank you very much for inviting me to here. Today, the title is Open Source Strategy to Spread the Technology of Electric Vehicles. As Professor Dasha said, I have been working in the field of electric vehicle for around 35 years. And during these ages, I have been working in electric to develop the fine electric vehicles. Now, it's a time of change, the world. Global warming is growing rapidly. Lack of oil is a very important point. And world economy do not grow up so well. To solve these problems, there are new technologies are existing and coming up. Well, one of the great technology will be solar cells. The other technology, I believe, is electric vehicle. The reason why we must choose electric vehicle is that the efficiency from the fossil fuel to drive electric vehicle is much higher than conventional internal combustion engine vehicle. And also, the other importance is that energy, renewable energy, can be used for electric vehicles. From this reason, electric vehicle is the one of the best solution for global warming and energy problems. This is the calculated efficiency of electric vehicle and internal combustion engine vehicle from fossil fuel. Generation, transmission of energy, charging, driving motor is required to drive electric vehicles. These efficiency are written here, and you can find each efficiency is very, very high. But in internal combustion engine and the loss of mechanism, the efficiency is less than 10%. So finally, the total efficiency is around 4 times better in electric vehicle compared with internal combustion engine vehicle. This is one of the reasons why we must choose electric vehicle. But electric vehicle so far have not been spreaded. This is the reason, this is only the reason, the performance is too poor compared with conventional internal combustion engine vehicle. Nobody wants to buy poor performance automobile, even if it is good for environment. So, if we want to spread electric vehicle, we must make the performance of electric vehicle better than internal combustion engine vehicle. Then, what is the performance of automobile? It's shown here. There are many criteria to consider about the performance of automobile. But finally, these 3 points are important. One is acceleration. The second is space on the cabin. The third is comfort. If these 3 values will be better in electric vehicle than internal combustion engine vehicle you want to buy. And another problem of electric vehicle is the range per charge. Range per charge must be reasonable to be used. So I have been working for 35 years how to increase these values in electric vehicle. Fortunately, there are several important technologies was invented within these 30 years. One is lithium-ion battery. Lithium-ion battery was invented 1986, and after 2000, large-scale lithium-ion battery was developed to be used for electric vehicles. Second point is that neodymium ferrite magnet was invented 1982, and after 1990s it was commercialized, but at that time it was too expensive. But after the year of 2000, it became very, very cheaper. That's why in high efficient refrigerator or high efficient air conditioner, neodymium ferrite magnet was used. And very high efficient inverter such as IGBT was invented also. So by using these inventions, the performance of electric vehicle will come better. Besides, I have been thinking the structure of electric vehicle must be changed from conventional style to be suitable for electric vehicle. For this reason, I have been doing what we say in-wheel motor. Motor will be set inside in each wheels. The second point, what we named component built in frame. We make a very strong frame structure under the floor. It is hollow beam shape. And inside the hollow beam shape, we will put all the battery. And inverters or other components will be put at the side of the floor. Then motors are inside in wheels. Batteries and other components are under the floor. By this way, efficiency of motor drive system can be increased very much, and weight of body can be a little bit lighter because battery container can be frame structure can be used as a battery container. And the center of gravity can be lowered because the most heavy battery is under the floor. And space on the cabin can be increased very much. So from the viewpoint of high performance, high acceleration, we can put 4 motors in each wheels, and the space on the cabin can be increased because there is no big components is set on the floor, and comfort can be realized because of the center of gravity is much lower, and wheelbase can be increased because there is no engine room on the body. So by using such a concept, I have been making high performance electric vehicle. I want to talk about in-wheel motor a little bit more. This is conventional onboard type motor. Transmission and or reduction gear and differential gear was used for conventional electric vehicles. But in our case, motors are set inside in each wheels. And in our case, stator is inside and rotor is outside. Because to increase the torque of motor, this shape is very effective. And rotor itself is connected directly to wheels like this.
この方式では磁石とタイヤが一体化するのでエネルギーのロスが大幅に解消されますが、一方でより強力なモーターの力を必要とします。
Like this. And the other point is that component built-in frame. In this case, as I said, all of batteries are set inside in the floor, and other components are set in this side, and all kind of body can be put.
車内空間の自由度が格段に増すのです。
Any kind of body can be put. By using this technology, I have been making 14 electric vehicles. At the beginning, we made the conversion type, then went to motorcycle. After that, 4-wheel or sometimes 8-wheel, 8-drive. The most famous car is Elica, which was done 2004. This is Elica. You can see the picture when it was test drive. I expected the maximum velocity was 400 km per hour.
But there's no sound of an engine. This is an electric car, propelled by motors and batteries. With 8 wheels and more than 600 horsepower, it's a genuine supercar.
But unfortunately, the maximum speed was 370. More important is that the acceleration of Elica. You can take a look the acceleration between Elica and Porsche 911 Turbo, the world's best sports car.
They're off. The Elica is the first to reach 160 kilometers per hour. Let's see it again.
At the beginning,
First, the Porsche sprints into the
is a
lead.
little bit faster because the body weight was too light.
After 3.8 seconds,
Our body
the
is too
Elica
heavy
matches the speed
because
of the
it is a
Porsche.
prototype. But after 90
the speed
kilometers
hits 100
per
kilometers per
hour,
hour, the
it
Elica
goes
pulls away
very
from the
quickly.
Porsche.
And when Elica reached
The Elica hits
160
160 kilometers per hour
power.
in just 7.04 seconds. At this moment, the Porsche is doing 138 kilometers per hour. The Porsche doesn't reach 160 kilometers per hour until the 9.2 second mark.
So now you can believe that the performance of electric vehicle can be better compared with internal combustion engine vehicle. Also, we have been making other type of cars. This is the bus. In this case, large-scale tire was decreased, and 8-wheel, 8-drive was done. Then this is the scene when it drives in the city. And the importance of this vehicle is that the floor is very low and full flat. It is very useful not only for environment but for normalization or barrier-free method. So this kind of bus is very useful in the city. And 2009, we made a company, SimDrive. This company is not to produce electric vehicle, but to spread the technology of electric vehicle to all over the world. For this purpose, this is the total business of SimDrive. One is what we say prototype development. In this business model, all kind of company, sometimes local government, will pay 200,000 yen, around 0.2 million US dollar per each. And around 30 companies gather to one project. And by using that money, we make a prototype, one car per year. And the result, all the result will be given to the participant. And the result will be shown, and some person who want to work with us from that company can come to our laboratory to develop all the vehicles. By doing such a way, technology can be transferred very well, very easily to each companies. The first project was finished last spring. At that time, the developed car is this one. We named Ray.
ガソリン車に引けを取らない走行距離と価格、自動車の未来を変えるかもしれないインホイールモーター型電気自動車、その実用化への道のりを追いました。
For this project, 32 companies and 2 local government gathered. And among the companies, Isuzu Motor Company and Mitsubishi Motor Company came, and many trading company joined, or component maker also joined, and some local government joined for the purpose of the new invention of industry. And for second project, it was finished this year from car company PSA Peugeot Citroën from France, and Dassault System also from France. Dassault System is very well known 3D CAD system, and Bosch came from Germany, and many Japanese famous chemical companies joined to this project. When car will change to electric vehicle, material will be changed. That's why chemical company have a great interest in our project. And now we are doing the third project. In this case, we put a new subject, which is smart grid. How to connect with car and smart grid was our new direction. From this reason, Sekisui House is the Japanese largest housing company, Sekisui House. Or Mitsui Fudosan is the Japanese largest real estate company, or developer company. Or many famous Japanese suppliers, for example, Denso or Sango are joined. And this is the first one. And second one is we named Shimwil. This is the second one, and finished this spring. And number is 14 because my 14th electric vehicle. And this one is the importance of this one is these 3 points. The range per charge was 350 kilometer per charge. In normal case, mainly in Japan, I asked to many people how long is required for electric vehicle as a range per charge. 60 or 70% person says 300 kilometer is enough. So our first target is 300 kilometer. Finally, we went to 350 kilometer per charge. So it's more than the standard in the case of range. And the other point is that space on the cabin is extremely wide compared with the same sized internal combustion engine vehicle. almost all persons says it is amazing because the size from the outside is not so big. But when he or she sat down in the cabin, the space is so huge. The third point is acceleration is good, almost same as the middle class sports car. And comfort is good because the center of gravity is low and wheelbase is long. So in this stage, if this kind of electric vehicle will be mass produced, many people will want to buy. So what we are doing is how to spread the technology of electric vehicle. That's why our method is open source. Everybody can join to our project, and everybody can get our technology, and everybody can use our technology for themselves. So even if car company, they can catch up our technology very easily. In the case of Japanese car company, they can do everything by themselves. They can do as same as us. But to come to our level, they must pay big money and they must pay long time. But if they join us, then just 1 year, they can get all of our technology. It's very easy way to catch up the technology. That's why I'm asking to many car companies, but car companies always says, we can do everything by ourselves. That is a problem. The merits to join our project still remains. One is that technology can be given very easily with cheap money. The second point is new information can be given because we are spreading all kind of information in electric vehicle. So this kind of position is very useful to gather new information of electric vehicles. So the participant can get all kind of new information of electric vehicle. The third point is to make alliance between companies. It is very easy because by using 1 year, around 30 companies are gathered together and work together. Then the participant can be known each other very easily. And once the company joined to our project, they can be our member forever. So the first project, for the first project, 32 plus 2, 32 company plus 2 local government joined. So totally 34. For second project, 34. Now 26. So totally our member are 94. So this organization is very important to spread the technology of electric vehicle, and sometimes they can collaborate each other. So this is the other merits to join our project. And also we are making some conversion of an electric vehicle. For example, we used DS3, Citroen DS3 to convert electric vehicle. In this case, 2 motors are set on the body. One motor is around here and around here. And batteries are located here and here, and this is inverter. By such a way, and by using our direct drive motor, conversion can be also be done. This is the picture of DS3, which was shown in Paris Motor Show this year. Charging plan is as same as the price of gasoline did. And inside, our technology was inserted. So finally, I want to talk about standardization a little bit. Why do we need standardization is that safety, easy to use the car, and easy to make. From this point, we must consider about standardization of electric vehicle. And about the safety, most important is high voltage when it is accident and when it was maintenance. And crash safety should be better than internal combustion engine vehicle. And electric vehicle sometimes said it is too quiet. So we must consider about these points. The other point is easy to use. One point is that charging method is important. Also, size of batteries are critical, and connection between smart grid is also the new point. Now, there are two standards of charging method. One is CHAdeMO. It is invented in Japan. This year, the new method combo came. Both are not so different. This is mainly Japan, and Tesla Motors is using this system, and PSA Peugeot Citroën is using. And General Motors, Ford, and German big OEMs are going to use combo. If there are two standards, it is very uneasy for users. So we must consider how to combine these systems. CHAdeMO is how about in Japan? Combined charging system is named combo. So we must combine together komcha. Komcha, konnichiwa is Japanese, konnichiwa, hello. So I hope this kind of standardization is important. And from the viewpoint of manufacturing, local area network and high voltage system and low voltage system are important. So we must consider about such a standardization also to spread electric vehicles. So thank you very much to come to this presentation. And finally, I hope we want to work with American companies together with us, because lithium-ion battery was invented in Japan, and highest technology is in Japan. And neodymium ferrite magnet also invented in Japan and developed in Japan. So high technology of magnet also located in Japan. So if such technology will be used for electric vehicle can be used much more. And from the viewpoint of industrialization and commercialization, American power is very strong. So if Japanese fundamental technology and American power will be connected together, I believe it's easy to spread electric vehicle to all over the world. Then finally we can solve the problem of energy and global warming. So that's why I came here to talk with you. This is the first chance for me to talk in the United States. Last year or before last year, we have several chances to talk in European countries, but this is the first chance. So it is very nice for me to come to here. Thank you very much for inviting me.
And I'm delighted that we have some time for questions. I'd like to ask the first question. So when you say that you're giving access to the technology to the members of the projects, I assume you're giving them drawings and all of the, actually able to participate. Do you also give them any kind of patent rights license to use the technology as well?
Yeah, I have around 40 patents and around 10 to 20 new patents was born in these several years. So all these patents can be used for everybody.
Because the cost of maintaining the patents is quite high.
That's why we must get to $0.2 million by participants.
Okay. I'd also like to ask a little bit about the kind of sort of user interface. Is your project also looking at how people react to driving the cars, or do you have any kind of consumer sort of studies that you're doing as well as the technology development, or is it purely on the technology side?
Sorry, please say.
Yeah, are you 一応消費者の態度も調べてらっしゃるんですか？プロジェクトの中で。
Yeah. When we start new project, I discuss with participant for 5 weeks at the beginning. At that time, the result of market also discussed. And for example, this one, size of this vehicle is B segment, same as same as this vehicle, Citroën DS3. So this kind of vehicle is very popular in Japan and Europe. That's why we select the size of sim wheel, the second prototype.
Okay. We can go ahead.
So you mentioned earlier that your company built two unique technologies. One is an in-wheel motor, and the other one is component built-in frame. So I understand that those technologies improve the performance significantly. But what about the cost compared to the existing?
Okay. Right now, electric vehicle is too expensive. It depends on how many cars you will make. If you make 10 times, in the field of industry, if the product number will become 10 times, the cost will become half. So if 100,000 cars per year will be done for one model, the price of electric vehicle will become the same or cheaper than internal combustion engine vehicle, because the structure is very, very simple and easy to make. That's why if mass production will be done, price will become lower.
Can I follow up?
Okay.
You visited Tesla today, and Tesla is using a traditional kind of approach where the motor is in one place and then there's a drivetrain to the wheels. Would they save money by going to an in-wheel motor, or would it cost them more?
Yeah. If mass-produced, the cost of motor itself is not expensive. Maybe less than $500 around 500
1,000 yen?
dollar, 500
okay.
per motor, less than $500 per motor if 100,000 cars will be done. So cost of motor itself is not expensive. But right now, Tesla is not so big mass production. So it is expensive. And they want to just one motor right now. But I hope they will change their mind to us in the future. That's why I visited Tesla today.
Okay, thank you. Bevan?
You have 4 motors. Let's see if you have 4 wheels. So the Tesla way is only have 1 motor.
Yeah.
So you have 4 times the probability for a motor failure.
Yeah, that's true. But the other point, even if one motor will be broken, you can go with other 3 motors, which is better. When you turning the curve, if one motor will be failed, some vibration occur. But if at that time you cut the current of the other side motor, almost no problem. So if we have 4 motors, even if 1 or 2 motor will be broken, you can go, which is better.
There was one other thing that I remember hearing is that you can use a weaker motor if you have multiple motors, right? To have one very strong motor is actually has different technologies rather than 4 rather smaller motors. Is that also a benefit, or do the motors really have to be the same size?
If you put 4 motors, very new driving system can be done. When you turn the corner, you can apply other torques to each motors. Then the performance of driving increase very much. In internal combustion engine vehicle, such a way is never be possible. But in electric vehicle, 4-field 4-drive means more drivability, or how to say, easy to
Maneuver.
control the vehicle is possible. This is the other merit, I believe.
Okay. Charlotte?
Oh, I think your opportunity is very exciting. One, I think you should make a visit to the Stanford D School. See if you can't find some takers there.
Actually, we talked with people from Professor Gerda's lab today.
Oh, wow.
So
my question is, are you familiar with the controversy that surrounds Better Place business model? Which is that the lithium-ion battery, you drive in and it switches out, and now you drive off with somebody else's battery. Mercedes won't adopt it. They think it's too big a safety hazard. What do you feel about that?
Yeah, you said Better Place business model? Yeah. Better Place business model is okay. No conflict with us. I hope they also use our technology. Their business will be much better. But I hope the name of the president, Agassi. Mr. Agassi came to our laboratory. They don't want to use our technology, unfortunately.
is that because your batteries are inside the frame?
Yeah. So concept is the same, almost the same. Tesla system,
Better Place.
Better Place system, battery will come from the ground. Our system is from the front and rear. So changing is almost the same way. So they can use our concept also. But they wanted to go from the bottom. But from the viewpoint of technology, I believe this is much easier. So I believe Agassi will change mind to our direction. Then their business will be better, much better.
Okay. Or Mark, you go first.
Okay. My question is efficiency and comparing the traditional one motor wheel vehicle and the in-wheel motors. Sounds like battery is smaller than one motor vehicle. So do you have any data between the in-wheel motor and the one motor vehicle?
Okay. If I if I can use
The board?
both, I can.
Could we raise the
I
screen real
can
quick and use
tell
the board?
why we must use in-wheel motor. Very easy. Your background is technology. Okay. Okay. So to accelerate and decelerate, speed 0, velocity v. To 0 to velocity v, kinetic energy is mv square divided by 2 times efficiency divided by the efficiency of motor system, acceleration. When deceleration, regenerative energy can be given for returned from kinetic energy to battery. The energy is so acceleration and deceleration total energy is efficiency. This point is very, very important. If you use one gear, efficiency at a low speed and high speed and low torque and high torque, average efficiency is 90%. Gear efficiency. Our motor efficiency is around 80%. So if you put 80%, if you use gear whose efficiency is 90%, 80 will become to 0.7. So it is clear that if you put 10% loss gear, energy for acceleration and deceleration is 0.4 and 0.6. So 1.5 times difference. Just you put one gear, the energy to use acceleration and deceleration, energy consumption rate is 50% difference. That's why we must remove gear between motor and wheels. So very easy easy calculation you can understand. But by talking, it is very difficult. It is a point. It is a point. Regenerative brake is very important in electric vehicle. Okay.
Thank you. Go ahead.
So one of the benefits, or were you putting someone behind me?
No, you're it.
Okay.
I'm just recognizing the person I saw next.
Oh, okay. One of the primary benefits of the system, the in-wheel motor, it sounded like, was how easy it was to, how separate the chassis was from the rest of the body, that you could easily put on a different type of body if that's what you wanted. Have you looked at all at retrofitting cheap cars that already have internal combustion engines?
Sorry.
To retrofit cars that have ICE?
Yeah.
That's
Retrofit.
what the DSE is, right?
Retrofit is also possible.
ガソリン車に引けを取らない走行距離。
国内外の34の企業と機関により
There we go.
Oh, sorry.
Yeah,
retrofit also possible by using the old traditional, そうですね。traditional body. It's possible.
Do you have an estimate for how much that would cost if you were to production quantities?
In this stage, motor itself is too expensive because it was not mass produced. But after 100,000 cars will be done, and then price of motor will become dramatically low. At that time, retrofit is reasonable. But in this stage, motor itself is very expensive because of not mass production.
do you know if anyone is thinking seriously about starting a business around retrofitting automobiles?
Yeah. Very many persons are considering about it. But actually, the cost is not easy because component cost is still expensive. So after mass production in electric vehicle will be done, retrofit will be more reasonable because lithium-ion battery is still very expensive.
Okay, thank you. Back in the back.
I read that the book about the intelligent foil proposed by the Michelin. Do you know the intelligent foil that is integrates suspension, motor control suspension, foil motor, and so do you have any comment on that?
Yeah. Most of person from car industry says, if you use in-foil motor, what you say, unsprung mass is the problem. Unsprung mass, do you know? Unsprung mass is the weight between spring to the ground. It means the weight of body, weight of tire, wheel, brake system. These are unsprung mass. If unsprung mass will be heavy, when you drive on a rough road, it is very uncomfortable. It is correct 40 years ago because suspension system was leaf spring and rigid suspension. Right now, coil suspension is used and independent suspension. And rough road is almost no. Almost all roads are paved. At that time, unsuspension weight is no problem. Heavier unsprung weight is good. Is better in comfort when you drive with high speed. This is our calculation and the result of our testing. Michelin system is how to reduce the unsprung weight. But no, that is not a problem. But such Michelin system is too complicated. That's why I don't think it is not be useful. Too complicated system is not useful. That's why I'm using very simple technology.
Thank you.
Okay.
So you mentioned earlier that if you have 4 motors and 1 or 2 fail, depending on which ones fail, the car can still drive. So why is it that you use 4 motors for 4 wheels? Couldn't you just have 2 motors for 2 wheels?
Possible. This one 2 motors. Yeah, so any kind of driving system is possible. 4 wheel to drive, 4 wheel 4 drive, 8 wheel 8 drive is possible. Any kind of choice is possible. And I believe 4 wheel 4 drive will remain in the future because driving performance will become good if controlled very well. So finally, I believe for-field for drive will be remain. But for-field to drive is also possible.
You're using a computer control instead of a differential to make sure that the wheels are turning at the right speed and providing the right amount of...
Yes. Yes, and not so complicated now. But in the future, now we are going to make a very fine control system, which can drive much better internal combustion engine vehicle. Because acceleration and deceleration of each wheel can be controlled.
Can you tell us a little bit about how many people are working for the SimDrive program now? About how many people do you have and their backgrounds?
Our employee is 50. Among 50, engineers are 40. 90% of our engineers are from car industry, Japanese famous OEMs, Toyota, Nissan, Honda, Isuzu, Mitsubishi. And 10% are from electric company, Toshiba, Mitsubishi, Toshiba, Honda, Toshiba, Hitachi, Toshiba, NEC, Fuji Electric, Fuji Electric, and Sony. No Panasonic. Why not? Okay, so I myself is not a car professional, but all our staffs are very highly experienced professionals. That's why our technology level is not lower even compared with OEMs.
How would you talk about the adoption of EVs in different markets, like in Japan versus here in the United States? Do you see the adoption as on track, or is it slower than it should be, or is it what you would expect?
Yeah. When you remember the spread of cellular phone, it started 1995, and within 7 years, you had cellular phone by yourself. In the case of digital camera, from 2000 to 2010, 2020, 2007, you would have digital camera. Now you are using LCD TV. If technology start to change, it will change within 7 years. This is the history of technology change. So right now, almost no car is electric vehicle. But once it take off, then spread very, very rapidly with 7 years. Because people change, user change the velocity. Maker cannot control the velocity of spread. Once user want to use electric vehicle, automaker must change by themselves. Otherwise, they must bankrupt. And if electric vehicle with high acceleration, spread high big cabin and big space on the cabin, and very comfort, and range per charge will be reasonable. Maybe you want to buy it. If this kind of vehicle will come to the market, take will occur, and after that, with 7 years, old technology will be disappear.
Where are the biggest technological still bottlenecks that could drop down the price substantially?
Nothing, I believe. Only money. For me, only money. Always, I'm very, very difficult to get money. Big investment will be done. For example, some OEM or somewhere, it is easy to be a market. There is no big problem from the viewpoint of technology right now.
Wow. Okay, go ahead.
I guess I'm biking around here and I see a lot of cars these days. Just there's one person in the car. And when I went to Asia, different parts of Asia, I'm noticing that there are a lot more motorbikes on the road. Could you talk about more of like one-person transportation, namely like the motorbike, but it can balance, like sort of integrating the gyroscope in there. Are there any kind of that technology being implemented and researched in Japan right now? Other one. Thanks.
My case, when you consider about LCD TV, space of screen extended, but the total size of TV set decreased. At the same time, in our vehicle, all of components are under the floor, and size of tire itself also very small. This vehicle, the width is just 80 centimeter, so you can get inside in your home. And length is 1.5 meter. But the size inside is almost same as business class seat. Is possible within such a small space. This is my final goal of automobile, and plus automated driving. Then no accident, no traffic jam, and you can go anywhere. This is my final target. But right now, I believe such kind of vehicle or sports cars will be sold easily. That's why we are making like this. But final goal is a small one and but still wide space and easy to go anywhere.
Go ahead, Ed. You were first.
The semiconductor industry improvement has been driven by Moore's Law. Is there anything similar in the future for battery technology? Do you use the battery technology right now similar to Tesla for lithium ion?
No. About the battery, I don't make battery by ourselves. It is same as Tesla. Simulate 2011, we used battery from Toshiba. Second sim wheel 2011, this is from Panasonic. It's same as Tesla. And now we are making number 3. We are going to use GS Yuasa. And we can select any kind of batteries. But if we will make battery itself, I must spend all of my life. So that's why my concern is how to make reasonable automobiles by using existing batteries.
So kind of to follow up your question about personal transportation, very small scale, what about using electric vehicle technologies for heavy transport like large trucks? This is, yeah, I'm looking, but buses are really not carrying that heavy a load.
The total weight of this bus is 12 tons.
Okay.
Yeah, in Japan, the maximum weight of automobile is 20 tons. so not so much
Okay.
different. And if we make truck by this concept, the space on the cargo space can be extended
Much
very
bigger,
well.
yeah.
So this concept is also useful for trucks.
You did have 2 truck companies in your project too, didn't you?
Right now, Isuzu joined.
Okay, Isuzu, yeah.
And in the future, we will make trucks also, if we can get good money.
Okay. Go ahead.
So earlier in your presentation, you mentioned that you were aiming for an open source model.
Yes.
So from my experience with the open source software licensing, there's a lot of different kinds. If people were to, the partners that you get, from what it sounded like, they get access to almost all of the drawings and the understanding of the technology involved. Once they get that, are they allowed to modify it and resell it? Do they have to keep it the exact same way? What are the parameters they're allowed to use it in?
Yeah, everybody can make their own electric vehicle by their technology, by using our technology. It's possible. That's why I must do new technology year by year, not to delay. This is our difficulty. So we must go very quickly to the next step. This is our strategy to keep our company.
Charlotte?
So along his question, so do some of your members give back additional improvements that they've made to the open source platform? And they keep some of it? How does that work?
使ってもいいだけじゃなくて、使って戻して、さらに開発した後で。
Yeah, they can modify our technology as they like. Yeah.
それからプロジェクトに戻すわけです。
No need to return to us. Just they must do is to pay us $0.2 million. Just it, and anything.
Yeah, you mentioned once participant paid $0.2 million, they can use the resources of your society, and also they can use a patent.
Yes.
So how is your business model?
Yeah. Our first business model, I talked detail this one. This case, $0.2 million is paid. But and if some company want to make their own car by using our technology, I can transfer the technology, all the technology. At that time, I can get a very small transfer fee, and it will be sold. It will be sold. Some royalty will be. I will ask some royalty, but if they don't mind to pay, it's okay. It's just the discussion. But in normal case, by 1 year, almost everything can be understood. But it is very difficult to make by themselves because some professional technology is required. At that time, they must ask us to do real things. For this purpose, we can get some money for consultation, and all the drawings will be given, and many support will be given. After that, real car will become to be the market.
So I think if there are no further questions, I have one brief suggestion. In a few years, maybe we'll see cars that don't say Intel inside, they say SimDrive inside. And that would be a great thing to see.
I hope so.
Thank you so much for coming today.
Thank you very much.